Hello Internet. So in this particular video, I'll be building a custom model using PyTorch, and it will be an image classification model. The dataset I'll be using that dataset is available on Kaggle, and it consists of Santa Claus images. So the model will build a model which will predict whether the given model is of Santa Claus or not. So I'll be keeping this video as short as possible because I don't want to take much of your time. So the implementation will be in 4 simple steps: import libraries, then load data, build model, and train and evaluate model. So let's begin. So import numpy as np from tqdm, import tqdm from time, import time, then import torch from torch dot optim, import Adam optimizer, then from torch dot nn import cross entropy loss. So this will be our loss that we'll be making using. Then convolution 2D, then average pool 2D, then batch normalization 2D, then dropout 2D, then leaky relu, and linear. From torch dot utils dot data import data loader. Then from torch vision dot transforms, it should be torch vision, not torch vision. Transforms, import transforms, then from torch vision dot datasets import image folder. Now I'll tell you the libraries that I've imported. So import numpy. I don't think numpy will be needed, but in case it is needed, I have imported it and kept it ready. Then TQDM, we will use TQDM for display purpose. So during the time of training, we will be training over 5 epochs or 3 epochs. So that will train afterwards. But to understand the progress of our training per epoch, we'll be using TQDM. It will give us a good horizontal bar for the training progress. Then time will be making use of this time module to calculate the training time. So we will note the time at the beginning and end of training, take the difference. That way we'll come to know how much seconds the model has taken to train for that particular epoch. Then in torch library, so the optimizer that we'll be making use of is the Adam optimizer. Adam is good for deep learning because it deals with the problem of vanishing gradient and exploding gradient. Then in torch.nn, we have cross entropy loss. Then that will be the loss function we'll be utilizing for this model. Then con2D is convolution layer, average pool 2D will be the pooling layer, batch normalization dropout. Dropout is used for dealing with overfitting of model. Then leaky relu will be the activation function and linear will be the fully connected layer. One more thing, module. So module will be using to build our model, custom model. Then to read our images into data set, we'll be making use of this data loader. Then to transform the images to tensors, we will be making use of transforms, and in transforms, we will also help us normalize our image. So image folder, sorry, I mixed up over here. So image folder will help us read our image and convert it to data sets, and data loader will help us convert the data sets to our data loader objects. The device, I'll define the device over here. Device equal to torch dot device, and it will be CUDA because my system supports NVIDIA. It has NVIDIA GPU. So PyTorch currently for Windows, it supports only NVIDIA graphics card. So CUDA is a toolkit created by NVIDIA for to be for its graphics card to be used as GPU. GPU is graphics processor unit. So if you train the model on GPU, it will train faster when you compare it to if you train the model on CPU. So torch.device, although my system is entry level, it has graphics card. So it is compatible with CUDA. So let us use CUDA. It is entry level, so I'll try to keep the usage of GPU to a minimum. Otherwise, its memory will get maxed out. So torch.device CUDA, if torch.CUDA is available. So the part which I have highlighted over here, torch CUDA is available. This will give a boolean whether true or false. If a GPU is present and it is properly configured, it will give this as true. If not, it will give it as false. Else CPU. So I'll be posting the link to GitHub where this notebook will be hosted. And if you want to run on your system and if your system does not have a GPU, this particular line of code will tell which device to use, whether to use CUDA or whether to use GPU. Okay, now this is done. Coming on to the second part, data loader. So let me create the transformer object, transforms dot compose, and here you have to pass in a list. First, let me resize it, 128 by 128. Then transforms dot random horizontal flip. Then I'll rotate it, transforms dot random rotation by 10 degrees. Then I'll convert it to tensor. Then I'll convert it to, I'll normalize the tensors. Transforms dot normalize, and here I'll pass it 0.5, 0.5, 0.5. So first list which I have passed is the mean and second one is standard deviation. So this is the transformer object. Now let us create the data sets. So train images is kept in this particular path and test images is kept in this particular path. So let me just immediately create the data sets. Train ds equal to image folder, and here I will pass in the pathway, and then transformer object, transformer equal to tfm. Similarly for test, test plot. Then I'll also store the length of the train and test images. So I'll store the length of train ds. Similarly, length of test ds. So why I am counting the number of images in train dataset and test dataset is because at the time of training, we will be calculating training and test accuracy. And since we are going to train our model in batches, we will be incrementing the train accuracy for every batch. And at the end, we will divide it by total number of images in that particular data loader. So we get the accuracy in terms of percentage. Not in percentage, but it will be between 0 and 1. So if you multiply it by 100, then we will get it in percentage. Okay, transform. It should not be transform, it should be just transform. Done. Then index mapping. If you want to see how the index is mapped, that is the class labels, then select any of the data set and type class to IDX. So it will show not a Santa has been assigned as 0 and Santa has been assigned as 1. Now let us create data loader. Train loader equal to data loader, and first object, first parameter that I'll need to pass in train in data loader is the dataset. So for train loader, I'll pass in train dataset, then batch size equal to 30, shuffle equal to true. Similarly for test, I'll just replace the train to test. So make sure you keep the optimum batch size. If you increase batch size number, then your GPU memory might get maxed out. If you keep batch size too little, then your model will need more number of training epochs to train, and it will not give a good accuracy. Now let us build the model. So class Santa CNN, because we'll be building a convolution neural network, and here I will import module. Where is this module? Yeah, M is capital, sorry, my bad. Module. And here let me initialize it. Dot. Sorry, there was some network issue. Okay, now proceeding forward. So we will type super, and we'll be inheriting Santa CNN self dot init. Then let us start creating the layers. Self dot con equal to conf 2D. Input channels will be 3 because ours is a color image. Then output channel from 3 to we will convert it to 8. Then kernel size 3 by 3, stride 1, padding 1. Then after convolution we will use pooling. So AVG pool. Here you have to pass in kernel size and stride. So kernel size again 3 by 3 and stride as well. Then self dot batch. Let us pass in the activation function leaky relu, and then let us normalize batch. I'll type just bn batch norm 2D, and number of features will be 8 because output of this output channels of convolution is 8. So number of features here will be 8, and then self dot drop will be dropout 2D, and we will drop out 30% of our neurons. Then self dot fully connected layer. So linear input features at the for the time being, I'll type X over here, and output features will be 2 because the number of labels, class labels we have is 2. That is, one is Santa and another one is not Santa. So I'll tell you how to calculate this X. Def forward self and X. So let me just copy this. Then type output equal to output. Get this in this particular method. I'll explain what I'm doing, and return output. Okay, here I'll put a space because I'll be inserting 2 lines of code over here. So first one will be output. The X will be the input. We will pass it through the convolution layer. That will store it in output. Then we will pass this output through our pooling layer. Then we will pass that output through the leaky relu layer. Then we will apply batch normalization to it, and then we'll kill off 30% of the neurons using the dropout. And then we will pass this output. We will flatten this output using output dot view and -1, and here x, the same x that will appear over here, the number same will appear over here. But what is this value? So we have this formula for seeing the output, calculating the output of CNN. But in my experience, that formula has worked almost 70 to 80% of the time, and remaining 20% of the time it has failed to give the correct dimensions, output dimensions. So either it might be a one-off case, or maybe I did some mistakes while calculating. So this is the method that I use to see the output dimensions. So just type print output dot shape, and let me just define this model. Okay, I won't define this because I already dedicated a cell block for this. Let me just execute this. So let me create the model. Model equal to Santa CNN, and let me just create these cell blocks for our own understanding, because we'll be creating some rough work over here. Okay, for the time being, instead of x, I will type it as 100. Just 100, but we are going to change this 100 in the next 1 minute. So let me just define it. Okay, so in line number 10, this is okay. So for x, y in train loader, x, y break, and we will pass this x through our model. And after passing this, it will give an error saying the mismatch of actual number of neurons and this 100. But it will fail after this particular step. So we will get the shape of this output, which we will be entering here. So let me just execute this. Yeah, so we have got this runtime error. Ignore that for the time being. This particular thing is important for us. Ignore this 30 because 30 is the batch size, and 8, 126, 126 is what we are after. So replace this 100 and this 100 with 8 multiplied by 126 by 126. Now let me run this. Okay, and comment this out because this print particular output dot shape has played its role. Now that is done. Now let me again create the model again. And now if you see, it will not show an error if I pass this x. It is giving the probabilities for the 30 features. So let me just quickly delete these extra cell blocks which I had created for our own understanding. So I'll again define the model and move it to GPU. I just have to type to device, then it will move it to GPU because device defined in my system, it is GPU. Done. Now optimizer equal to Adam, and in Adam optimizer, the first parameter that you need to pass is the model parameters. So model dot parameters. Second one is learning rate. For Adam optimizer, the best learning rate is 3e raised to -4. That is 0.0003, and weight decay that will be adding is 0.0001. So weight decay helps in preventing overfitting of the model. And let us define loss function as cross entropy loss. Done. Now let us train the model. So let us train the model over 3 epochs. So for epoch in range 3, start time equal to time, then train accuracy, I will set it to 0. We will be incrementing this train accuracy every epoch for our train loader. Similarly for test loader as well. Now let us go to the train phase. So model dot train. So this will tell the system that we are training our model. Then with TQDM, because we want a good horizontal progress bar for our epoch, training epoch. With TQDM, train loader, and unit will be our batch as T epoch. T epoch is any variable. So with TQDM, you are storing it in this T epoch. And now I will iterate this over this T epoch. For X train, Y train in T epoch. So optimizer dot 0 grad. So I have to set the gradients of optimizer to 0, so that at the end of the this particular training, whatever gradients it has accumulated, it will change to 0 for the next batch. So the gradients of our current batch should not affect the training and gradients of the next batch. So it should not influence the model parameters that the next batch is suggesting. So for that purpose, we are using this optimizer.0 grad. Now, since I want to pass xtrain through our model, I'll need to move this xtrain to device. So make sure input and model both need to be on the same device. If your input and model are on CPU, then CPU or GPU, then they will run properly. Otherwise, if your CPU is on, if your input is on CPU and the model is on GPU, it will throw an error, and vice versa. That is, model on CPU and input on GPU. Both input and model need to be on the same device. So I moved it to device. Now I will pass it through the model and save it in train prob. Prob is probability, because we will get the output in terms of probability. That is, what is the probability for class 0? What is the probability for class 1? So train probability equal to model and then xtrain. After training, I will move this train probability to CPU and not keep it on GPU. I am doing this to prevent maxing out my GPU memory, because my system is very low end system. So I don't want my GPU memory to get maxed out while we are doing our training. .cpu. Okay. Then calculate the loss. So train loss equal to loss function. And the first parameter that you need to pass is this train probability. And second one will be the actual training, Y train. Do not interchange the positions, because this loss function is designed in such a way that the first parameter needs to be the output, that is a probability of the model. If you reverse it, then it will throw error. Then after we get this loss, I will type loss dot backward. This will do the back propagation, and optimizer dot step will make changes to the model's weights and biases based upon the back propagation. So I am commenting out this end train, because the training phase ends over here. The next few lines of code that I will be typing over here is that will be helpful in understanding the training accuracy. So I'll type train pred equal to, since train probability is the probability and we want that in this format, Y train format. So Y train format is in the form of tensor, either 0 or 1. So instead of the training probability, that is the values, I want which value, which class has the highest probability, whether it is 0 or 1. So for that, I'll type train prediction as torch dot max. And here I'll pass this not train loss, train probability. Train prob 1 dot indices. And then if I want to calculate the train accuracy, I'll increment it because right now it is 0 for every epoch. Then batch wise we'll be incrementing it with the number of correct predictions. So torch dot sum, and here I will put a condition, boolean condition, and I will try to match train prediction with actual y train. And just to remove the tensor, I'll put it in integer, so we get the actual value. So at the end of this epoch of the training phase, I will save this in train epoch accuracy equal to train accuracy divided by length of training dataset, that is all the files present in training dataset. Now this is done. Then let us move to the evaluation phase. With okay, first I'll need to set this model.eval. It will tell the system that the model is in evaluation phase. Then with torch.nograd, so it will tell system that we are not supposed to calculate any gradients. So for X test, Y test in test loader, let me move this X test to the device. Then test probability is when we pass this X test through the model. Then the test probability, we will move it to CPU. So we remove that from the GPU to make it computationally less expensive than on the GPU. So let us calculate test function, not test function, test loss. So we'll pass it through the loss function. First will be this test probability, second will be the Y test. Then after getting the test loss, we will get test accuracy. So test prediction equal to torch dot max test probability comma 1 dot indices. This is exactly the same thing that we have done over here. The only thing that we are not doing is training the model. That is these steps: 0 grad, then loss dot backward optimizer. These things are done to train the model. Here we are not training the model, we are just evaluating the model. So test accuracy, we will increment it. Here I have made a mistake. It should be test, not text. Integer torch dot sum, and here I'll put this again condition, boolean condition, double equal to y test. And to calculate train epoch accuracy, so instead of train epoch, we will say test epoch accuracy. Test epoch accuracy equal to test accuracy divided by length of test. Done. Now let us check what the end time is. Then take difference and minus start, and then print for our own understanding. Let me put it in f string epoch plus 1, because epoch will, in Python, the range function, if you are going to start from 1, it will start from 0. You have to explicitly write from 1 to 4, because it will, here it will start from 0, 1, 2. It won't take 3. Then epoch, then time. Time will be the diff. Then on next line, TR loss, that is the training loss. So train loss, then test loss will be test loss. Then on next line, training accuracy, it will be train epoch accuracy, and then test accuracy, which will be test epoch accuracy. That is done. Let us execute this and hope we get the epochs without any error. Even if we do get error, line. Okay. Oh, I forgot to add this double inverted. Okay, even if we get any error, we will debug it. Okay, let me just stop it over here because I think I have forgot to in some place I have put this print. Let me just in line number 31, I made a typo. It should be torch. Sorry, I can be a klutz at times. Okay, so at the end of first epoch, it took around 20 seconds. So training loss is 0.6, test loss is 0.69, training accuracy is 0.49, test accuracy is 0.45. Let us check for next epoch. Okay, for next epoch, it is 50 and 48, quite low accuracy. So this accuracy we can increase using the number of convolution layers. Since we have got such low accuracy, let us train for 10 epochs. And I'll just fast forward it to when this particular training ends. Okay, so welcome back. So I have trained this particular model over 10 epochs. Let me just use my specs. And the accuracy that we have received is for test accuracy, it is 83%, and for training, it is 85%. Now let us demonstrate the model performance. So let us first show for this first sample of image. These are the path for the 4 images. First 2 are of Santa, second 2 are not of Santa. Now I'll use the pillow library to read the image. So img equal to image dot open. Then for display purpose, I'll type image dot resize 100. So it will display the image for us. Then I'll convert this image to tensor. I will pass this through our transformer object, and this transformer object will convert the tensor. So the shape of this tensor will be 3 multiplied by 128 by 128, because we have mentioned it while defining this transformer 128, 128, 120. And 3 will be the input channels since it is a color image. So the shape of tensor which we have entered, which we have provided to our model is 4-dimensional and not 3-dimensional. So let us just add one more dimension to our model. So image tensor equal to image tensor, and I'll type np dot new axis. This will add one more axis, that is one more dimension. And then I'll pass this image tensor through our model and I'll save it in prob. So model image tensor. One thing I forgot, I'll transfer this image tensor to image dot to device. Done. Then because model is on GPU, so both this input and model needs to be on the same device. So the probability which we have received, we have to convert it into the class format, whether 0 or 1. So pred equal to torch dot max, and here probability comma 1 dot indices, and this prediction that we will be getting, let us put a condition: if pred equal to 0, print f string prediction as pred. I'll say model prediction, that means interpretation image is not Santa, and I'll just copy paste it and type in else print image is Santa if it is 0. Let me just execute this. Okay, so I have not imported the pillow file. Let me just quickly import pillow file from PIL import image. So this PIL is the pillow library, and from that pillow library, from spelling mistake, from PIL is a pillow library, and from that I have imported this image. Now it should execute. Unknown samples. Okay, so this resize needs to be a tuple. So let me just pass it as tuple. 1, 2, 3, 1, 2, 3. Okay, so model prediction. Let me just extract this instead of this showing as tensor. So pred item, pred dot item. Okay. So model prediction as 1. This is the Santa image, model prediction 1, and interpretation image is Santa. So it is performing properly. Now let us just loop the same thing over this sample list. For IMG path in sample list, and let me just print a demarker, and now execute for all the 4 images. So first image Santa, model prediction 1, image is Santa. Second one Santa as well. As you can see, model prediction 1, image is Santa. Then third image is cat. For some reason it has identified it as Santa. Fourth one is not a Santa because it is Roger Federer. Let me just check why it is showing it as Santa. Let me check it for 10. No, okay, no such. Just 110. Okay, so for this third image, now model prediction 0, image is not Santa. So our model accuracy is test accuracy is 83%. So there is some error for the 17%. I guess that image of the cat fell under that 17%. So for the first 2, it is predicting correctly images of Santa. And last 2, where we are saying image is not of Santa, model is also predicting that the image is not of Santa. So that's it for this video. If you like this video, please like it. And I hope this video helps you out if you want to build convolution neural network. using your own means building your own custom model. To increase the complexity of the model, you can add furthermore convolution layers, then fully connected layers, that is the linear layers. But as you increase the models, the computation cost will also increase. But you will also get better accuracy. That you have to maintain proper number of layers, because higher the number, more chance of overfitting, that also comes into picture. As you keep on practicing, you'll know how to get a good balance. That's all for this video. If you want to collaborate, you can send me an email on shaunak.python@gmail.com. That's all for now. Thanks. See you soon.